Hi. Can all hear? Can see my slide and hear me? Good morning, everyone. Good. So in this lecture, I'm going to carry on where we stopped on Tuesday. Today, I will just introduce you a few functions about how to use the linked list. In the last lecture, we have show you how to create a linked list, and I also show you how to print out all the nodes, the item in the linked list. By this, you just need to write this particular function to write a while loop, and then every iteration you're just trying to print out whatever things inside the nodes, and followed by update your cursor, update your pointer to the next, because the link pointer, the next pointer contain the memory address of the next nodes. So from that, I can bring my pointer to the next location to print out the next item, the content in the next item. So in this example, first my current pointer is point to the first item. I will print out 20. Next, through the line 4, I update my current pointer to the next pointer, to the next location, so that I'm in the next iteration, I will be able to print out 30. Then next, I update it to move it to the next location. I can print out 60. Then the last one will print out 70. When I reach to the last nodes, because the next is the null pointer, so it's a null pointer, my while loop will stop there. So the program will end, and not surprising that the output will print out all the item in the linked list, 20, 30, 60, 70. So that is the very simple print function to print out all the item in the linked list. Okay, next one, we want to definitely another application, another utility function you need to have is trying to find. For example, I want to find what is the content in the I nodes. So I need to do some search. That is one of the function I need. So now I'm trying to write a function which can let me to look for the I nodes in the list. So that means I need to run a loop to find where is the I item in the linked list, and then return the content of that particular nodes. If that particular, maybe out of the range, maybe I is less than 0, maybe I is more than the size of the linked list, in that circumstance, I will simply return a null pointer. If that is what the objective I need to do in this particular function, then yeah, I just need two arguments. One is the pointer, the head pointer, where you point to the first item, and the index. In this example, I let the first item, the index as 0. The second item, the index is 1, and so on and so forth. So the index is start from 0. In fact, there's no fixed rule. Have to take note that there's no fixed rule that saying that you have to start from 0 or start from 1. So that is my definition. I just start from 0. And in that case, yeah, let's say my I equal to 1. That means I'm looking for this particular nodes, the second nodes, 30. Yeah, this one. So in that case, okay, maybe I write the program. My I is 1. My current pointer is point to the first location. Of course, first, the current pointer is not null pointer. Yes, I is not less than 0. So this particular if statement won't execute. I will directly go to this while loop. This particular while loop, what will it do? First, they check whether the I is greater than 0. At this moment, it is not. It is still equal to 1. Then I move to the next line. Then I will just update my current pointer from here to here. From here to here in line 6. So they will move to the next nodes. And this particular nodes is not a null pointer. So this if statement wouldn't execute. They will just go to line 9 and update my I to minus minus, which is reduced by 1. So now the I becomes 0. Next, I will rerun this particular while loop again. At this point, the I is equal to 0. So I already reached the nodes I'm looking for, this particular one. So I will just return it. Yeah, so that is the 5 nodes, how it works. So these are the print list 5 nodes. Basically, it's just, in short, it's just trying to run a while loop, repeatedly search, repeatedly move your pointer from one point to, from the first nodes to the second nodes to the third nodes, and do the job accordingly. Probably the hardest part in this lecture is the next one, which is the insert nodes. Another typical application we need is we need to add some data into the linked list. After we create a linked list, we need to add the data into the linked list. So how to insert a new node into a linked list? So you can see the objective I need. Of course, to create a new node into a linked list, first you need to let me know where is your head pointer and where you want to insert the nodes, the index, the location, the index you need to get me. And then the third thing is all the required data you want to insert into these new nodes, the item in the new nodes. So, and my return value, just here I just simply return 1 as a success, 0 as fail. Yeah, usually you are success if you not run out of memory. So first I need to create a node. Yeah, so to do so, I need a index, no problem. The item, no problem. The key, you have to take notes here. You will find out that I need the pointer, pointer to a pointer. Earlier, if you go back, you will find that always I just need a pointer. Here I just need a pointer of the list nodes. But in the insert nodes, I need a pointer to a pointer. Later I will explain why is it so. Because you can find that you want to create a new node, there are a few possible scenarios. You have a linked list. You want to insert the item in the middle. At the back, no too big difference. The big problem is if you are insert the very first nodes, or you want to insert a node at the front, at the very beginning, which implies that your head pointer, you need to update it. It no longer point to the existing nodes. You need to point to the new nodes. In that circumstance, that's when your head pointer need to be updated in this particular function. If that is the case, you have to pass the reference, pass by reference, the reference of a pointer, a reference of a pointer. If that is the case, you need to pass the pointer to a pointer. So that's why this is need to a double pointer. If you recall what you have learned in earlier, when you call a function, you have two options. One is pass by value, the other one is pass by reference. When you just simply pass the value of a variable, basically this particular function will not be able to do anything about that variable on that particular variable in the main function. You only pass the value only. You only modify, you only use the value to do some calculation, to do some some application, whatever, on inside the particular function. But when you return back to the main function, the original variable remain unchanged. So when you pass by reference, what is the objective? You need to pass by reference. You pass the reference of that variable to a function. The purpose is you want to let that particular variable to do the modification on the variable. So you want to change a variable, the value. So when you return back, after you have done something on the function, you return back to the main function, you will find out that that particular variable, the value change because you pass by reference. So today is the same thing. Today I'm trying to pass, in the earlier, I'm just pass the pointer, a pointer of the head pointer, the pointer of the first, where you point to the first nodes. In the end, when I return back to the main function, that head pointer still point to the same location. But if today I need to modify this head pointer to point to another location, which it may happen in the insert nodes. In this circum system, I need to pass the pointer to a pointer of the head pointer, so that I can modify the head pointer in the main function. That is why there's a double pointer here. So that is mainly due to the first case, when you insert a node at the front. Because basically later you will see that you insert the nodes in the middle or insert the nodes at the back, there's no too big issue. Yeah, maybe I show you use the diagram to illustrate how to insert a node in the middle. You will find that it's exactly same as insert a node at the back. So if you have a linked list, you want to insert a new node, which is content 25 here, into this particular linked list. By doing so, yeah, maybe somewhere here, I need to insert this thing to here. If I want to do that, the step first, I need to let my new nodes, the next point to here, which is point to the same location of these 20 nodes, to the same place, to the next location will be here. Next, this is the first step I need to do. I need to update this particular null pointer. Initially, this one should be a null pointer. Then after that, I'll update it. That's the first step. The second step I need to do, I need to redirect this particular link from here to here. So this is the second step I need to do. Once I do this, you will find out that the linked list will insert 25 successfully into the linked list. So I just need to do these two steps. Similarly, from here to here to here, two steps. You create, okay, more precisely, first I need to create a nodes. After I create a nodes, I will let my new nodes next, the link to the next nodes 30, and update the previous nodes of this 20 in point to the link of these 20 nodes, point the link to 25, the new nodes. Then I will insert these new nodes into the linked list at this particular location. Similarly, to insert a node at the back, in that case, same thing, I will insert, I also create a new node. Here I create a new node. When I create a new node, the next step, I can let this one to be a null pointer, because this will be the last nodes. These new nodes will be the last nodes of the linked list. So this one definitely is a null pointer. In other words, basically I just copy whatever here, because I want to insert the nodes after this guy. So since this one, the next is the null pointer. So I just copy the null pointer to the link of the new nodes. Then I will update this last nodes. Instead of null pointer, I will point it to the new nodes. If you compare this one, it will be exactly same as the insert a nodes in the middle. So in other words, insert the nodes in the middle or at the back are exactly the same. The key is if you want to insert the nodes at the front, yeah, you have more problem because there are two possible scenario you need to consider. Maybe you have an empty linked list. The head pointer is point to nothing at the beginning. So you have an empty linked list. If you want to insert a node, there's a problem. If you want to insert a node, there's a content, there's something there, but you want to insert it at the beginning. Whether it's this case or this case, you will find that this particular head pointer, you need to update to the new location. It no longer point to the null pointer or point to the first nodes here, the old first nodes. You need to point to the new first nodes. If that is the case, yeah, I need to do something. That's why I mentioned earlier, I need this pointer. The pointer to the pointer where you store the memory address of head pointer. So you can think that, yeah, these are all the linked list nodes. The first node is here. Is in somewhere in this location. Maybe there's another node somewhere in this location. Yeah. Then your head pointer, where you store the memory address pointing to this particular location, which is 1080. This 1080 is stored in this particular location, 1000. This is the head pointer. This is where you store the value, the memory address of the first nodes. But you need to modify this particular memory address 1000 today. When you insert a new nodes, you need to update the head pointer. It no longer point to 1080. You need to point to another new nodes. You need to update this particular memory address and not this particular memory address. You are updating this one. So when I pass from the main function, I need to pass another pointer, which is pointer of the pointer. Pointer to a pointer. I need to pass this one because this one is the one content the memory address where you store the head pointer. So if that is the case, yeah, in my function, I need to use the pointer to a pointer. It's due to when I insert the nodes at the front, I face up this problem. I need to update the head pointer. So let's see. So if I only pass the head to insert nodes, I will only be able to access these particular nodes. I can change the content, I can change the next, I can do something, but I cannot change my head pointer if I only simply pass the head. I can do something after this in the linked list, but I cannot change the head. But if I insert the nodes at the front, I need to change the memory address. I need to update this memory address 1080. I need to update it because I create a new nodes. And this new nodes, I need to let this head redirect point to this location. I need to update these particular things. To update this particular content, I need to pass this address. So I need to find where I store this address, which is pointer to a pointer. Okay. Otherwise, I won't be able to change. I will not be able to modify the content because I only pass my value. I only pass the value, the 1080 to the function. I cannot do anything. But if I pass the value pass the 1000, the memory address of the head pointer, where you store the head pointer, I can modify the content in the head pointer. So that is something very important, the key concept you need to understand in this part. Okay. So that is the insert nodes we have. Just now what we have done to insert the nodes at the middle and at the back, in the middle and at the back. Basically, you just create a new node and then put the item into it. First, you let the current pointer, the link, you assign this particular link to the new nodes next, and then the current pointer next will point to the new nodes. That's it. That is what you can see. You can see the animation I show you in the earlier slide when I insert a node at the in the middle and at the back. And here now I need to, if there's a case I want to insert the nodes at the beginning, like what you see here, in that circumsystem, of course, and same thing, you need to create a new node. You need to create a new node, put the item, like this one, I create a new node. Then the next step is this one. When I reach here, I create a new node. Then I let the new node next point to the same location as the current head pointer. Then the next one, which is the key why you need the double pointer, is because of this particular line. Because you need to update the head pointer to let this particular head pointer point to the new location and then return. So you need to update this head pointer. That's why you need to pass the pointer to a pointer, the head pointer, so that you can change the head pointer. Once you update it, then the new node is insert at the front. So the pointer of the pointer to the head is used for the link once the element is insert at the beginning. To link, mainly the pointer to a pointer is because I need to update the head pointer in the main function. So that's why I need to pass the pointer of the pointer, because that particular head pointer, you can see that the key is this step. I need to update it in the function. So when I return back to the main function, the head is no longer point to 20. You will point to 40. If you don't pass the pointer to a pointer, when you return back to the main function, you will find that the head pointer still point to the 20. It still contains the memory address where you point to 20. You won't be able to update it. So that is the reason. Can you return the update pointer value? Can you return? Well, another way, if you use you can return. There's some people also do that. That means instead of return the success or fail, they return the pointer, and when they go back to the main function, they update the head pointer accordingly. That also can be done. Depend the function we give you or you implement. Both are workable. In the tutorial, I even ask you to implement it in the recursive way. There are a lot of ways to insert the nodes. All this can be done, yes. Require allocate a bigger chunk of the memory, then copy the, no. This is about, is it good practice to initialize as a global? No. Normally, we try not to declare too many global variables. Especially, it's not a good practice. Because when you create the global variable, you make your, one thing is make your program very messy. Second thing is, it can be very complicated because every time you create a new function, you have to be careful. You have a global variable around. So probably declare a global variable is not a good practice, and you will consume your memory all the times. That may be not a good idea to do so. I would say that it's not a good practice to declare a global everything create a global variable. Yeah. So okay. So that is how this part I have mentioned in the earlier slide. Yeah, if you want to insert a node, first you need to know this location. Another thing I forgot. Okay, back to in fact, if you look at this particular function, this condition, you will find that actually this one is redundant. Yeah, actually I don't really need this particular one. Whether the head pointer is a null pointer or not a null pointer is okay. Because when you hear if it's a null pointer, I just assign this one to a null pointer. If this is not a null pointer, well, you will just not assign this thing to a null pointer. Yeah, so actually, whether it is a null pointer or not a null pointer is not important. As long as your I equal to 0, I will insert the nodes at the front. So here I just simply let I equal to 0 is good enough. So that is the insert nodes. When I insert the nodes, like what you see in the earlier slide, trying to insert it in the middle or at the back, you first you need to know where is the nodes. If you want to insert the node somewhere here, then you need to know where is previous nodes. So you need to use the find nodes to search for it, to find this location. And then you declare a new nodes you need. I declare a new nodes. Just like what you see in the earlier slide. Then the link, where this previous nodes, the link of this previous nodes, this 30.2, this one, I will just take it and then assign to the new nodes link. And then update it. Update this particular one to here. Then 40, this particular new nodes is successfully inserted into this location. Okay, so that is the insert nodes. Similar to the remove nodes. I'm not going to too details because that is your next week the lab. I would like you to try to implement the remove nodes in the lab section. But the idea is very similar to the insert nodes. Basically, you will find that you just need to consider 3 scenarios. You're trying to remove a node at the front, in the middle, and at the back. Yeah, then very soon you will find that middle and the back are the same scenario. Only at the front you need to take notes that the head pointer need to be updated. So basically, usually we do all these linked lists. You maybe need to draw out some example and then trying to think about how to update your pointer. The order is very important. Which one is supposed to update first? Because for example, in this case, if you update this before you update the link of this previous nodes, before you update this one, you make sure that you already assign this value to here before you can update it. Because once you update it, no one knows where is the 50. So you have to, before you update it, you already assign this value to the new nodes link. Then you update it. So the order is very important. If your order is not correct, you will find that you will lose the connection to the next nodes. So similar to the remove nodes. This one I will not show here because I want you to try it out during the lab section next week. Okay, so the last one is the simple ones. You just check the size of the linked list. So by doing so, in this case, you just need to give me the head pointer. I don't need I'm not going to modify anything. I just trying to count the number of nodes in the linked list. So if that is the case, I just simply declare a counter and then run a while loop. and every iteration, if there's a nodes available in the next link, I will just increase my counter by 1 and repeat until I reach the null pointer. Then I return the counter. That is the size of the linked list. So every iteration, I just increase and move to the next nodes, move to the next nodes. Yeah, if it is a null pointer, I can stop and return the counter. So that is the rough idea I need to do to find out the size of the linked list. So I just need to have a counter and then run a while loop. Every iteration, increase the counter by 1 and then move to the next node. Until you reach the null pointer, you can stop and return. That is the size of the linked list. Yes. Yeah, remove nodes also need the pointer to a pointer. Yes. And then the lab material already, the first lab is already uploaded. It's okay. I'm not going to update the head pointer. In the end, the head pointer still remain unchanged. I just need to know the size only. In this particular function, the objective is just know the size. I don't need to update anything. So I don't have to pass the pointer to a pointer. Just like find nodes. You can think about it. Find nodes, print nodes, size, all this. You are not going to modify the content. You are just trying to read the value from the linked list. So when you're trying to read, you're trying to check something, whether it's available or not available, the number, the size of the linked list, this kind of thing, you are not going to modify anything, the content. The content should remain unchanged after you call this function. In the end, they still remain unchanged. Everything remain unchanged. You just obtain some information about the size. Yeah, whether the search something in the linked list. You are not going to modify anything. In that circumstance, you don't have to pass the pointer to a pointer. You need to pass the pointer to a pointer is because you need to modify that particular pointer. Like head pointer, I need to modify it. It no longer point to the same location. You point to the new nodes. I need to, in the function, I need to let it point to the new nodes. In that circumstance, I need to ensure when I go back to the main function, the head pointer in the main function is updated after this function called insertNodel or removeNodel. If that is the case, I need to pass the pointer to a pointer. But okay, back to this size linked list, you will find that actually this is not a very smart approach, because every time I need to check the size, every time I need to run this particular while loop, imply that the computational times, later next week I will cover the analysis of algorithm. You will find out that this particular one, every time you want to check the size, you need to run n iteration. If you have n nodes in the linked list, that means you need to run n iteration every time. But the number is still there. If you're not going to insert a new node or remove any nodes, every time you call this function, you need to run n iteration. It can be a lot. If I have 1 million data in this linked list, that means you only know the size of the linked list is after 1 million iteration. And you need to, if you check the size multiple times, that means every time you need to run 1 million times, 1 million iteration to know the answer is 1 million nodes there. So to overcome this, okay, maybe I have, maybe this one later. Yeah, to overcome these particular things, actually I can try to add another structure, which including the list nodes plus the size. Yeah, I just need to add another size in the new structure. I use this to create my linked list. That means every time I insert a node, I update the size. Every time I remove the nodes, I update the size. Initially, when I initialize this particular structure, I initialize the size as 0. Every time I insert a node, I just simply increase by 1. I remove a node, I just simply decrease by 1. Then, in that circumstance, when I check the size, I don't have to do anything. I just simply return this particular variable. It's good enough. I don't need to run a while loop. That can help me to improve the computational times. Yeah. The big O notation will cover in the next week lecture. So that is, we introduce a new structure. That means I trying to use a little bit more memory, but I improve my algorithm. From n iteration, I don't need any iteration. I just need to take a constant time. Just return the value. That's it. Yeah, there's no any for loop involved in this check, the list, the site list. Yeah, then every time you insert the nodes successfully, you just simply increase this particular variable by 1. You remove a node successfully, you just, before you return, you just simply update the sites. Then that can help you to improve the algorithm, the computational times of this sites list. And by using this particular structure, you will find that, yeah, the print list, originally you pass the head pointer. Now you just need to pass this linked list. In fact, you still pass a pointer. Okay, although here there's no pointer here, but actually inside there's a pointer. Yeah, same thing. When you insert a node, you pass the pointer of this linked list. But actually it's the pointer to another pointer, because inside this pointer, there's this particular linked list pointer. Inside there's another head pointer. So actually it's still pointer to a pointer. Yeah. So I think in the lab, I also let you try to rewrite the program. Yeah. Originally, this is the one I give you in the earlier slide. If you introduce the new structure, in the new structure, actually, yeah, that is the function. It's almost exactly the same. Yeah, it's just like you introduce another, on top of the head pointer, I just introduce another structure. Inside this particular new structure, they have another new member called sites. That's it. So algorithms are exactly the same. You just introduce the sites here. For print list, there's no issue. For find nodes, yeah, you can, yeah, this one can help you to do a little bit better. When you're out of the range, in the original one, you have no idea the size of the linked list. So you won't be able to know that the given index is already out of the range at the beginning. But after you introduce the sites, you can fully utilize the sites to check whether it's out of the range or not. You don't have to run this while loop if it is out of the range. Yeah. So this one, I left it here for you to go back and try it out. Same thing in the lab, I also asked you to try to write the remove nodes. Yeah, these are the things you should practice. And yeah. Okay, then back to just now where I stop here. So why do you need a linked list? Basically, you will find that, for example, if I want to print all the item in a linked list or in an array, basically the algorithm are about the same. No choice, you have to run a while loop and then print out everything. Whether it's a linked list or array, this one no issue. To search, basically array, if you know the index, you can directly access that particular element. But this is the weakness of the linked list. You have no choice. You have to, linked list is the one node linked to another node. So you have to travel at the beginning to go to that particular location, that particular index before, yeah. So then you can access the nodes. So usually you will take more times to do this kind of search compared to array. Array, you just give me the index, I can directly jump to that location and then retrieve the data. So this is the difference between the linked list and array. But the good thing for the linked list is at the insert nodes and remove nodes. For array, you want to add a new nodes, or you want to remove something from the array, is not possible. Basically, it's not possible you can remove a nodes in the middle, or you will find it very troublesome. If you really want to remove it, that's when you need to create another new array and then copy everything from the old array to the new array, and then you can so-called remove a nodes. But for linked list is very convenient. You just tell me which nodes you don't want. I just simply free that particular nodes. I don't have to do anything. I don't have to create the whole thing, copy the whole thing to a new array. Linked list, you don't have to, because all the nodes are standalone. You can easily add the new nodes. You also can very easy to remove one nodes from the linked list. Yes, you have to delete nodes or remove nodes. You have to use the free. Insert nodes, I use the malloc. Implied that when I remove nodes, I have to use the free function. As I mentioned in the last week lecture, the malloc and free work in pair. You malloc how many times in a program, you expect that in the end you have to free it the same number. The same number of time you call the free function as the malloc call. So check the size. Well, array, when you declare, you already know the size. Linked list, every time you insert and delete, only when you need to update the size, like what you see just now. If you use the earlier algorithm, that means every iteration you need to run a while loop. That is even worse. But this can be improved by what you see just now. I just declare a new structure. Then I can improve this particular while loop. I can remove this particular while loop. Every time I insert the nodes or remove the nodes, before I return, I just simply update my size. Then I don't have to, when I check the size of the linked list, I don't need to run this while loop and check. I have a variable. I just need to spend probably 4 byte memory to store the integer size. Is good enough. There's a student asked, would be a good idea to keep a pointer to the end so we don't need to loop to insert a new node at the end? Yes and no. Later you will see when I think in week 4 we cover the stack and queue. When we have some, of course in some application, you will find that if you know that your insert nodes in your application is always insert the nodes at the back. In that circumstance, but properly, it's good that you have a tail pointer to know where is the last nodes. So that is depend whether all this structure, don't blindly trying to memorize all this. It's just I wrote it myself. So it's depend on the application. I may adjust all these function depend on my problem. So if I know that I always only insert the nodes at the back, of course I need to know the tail pointer. It's better than every time you travel from the head all the way to the end. That again will increase the computational time. Initially you'll find no too big problem. When you have 5 nodes, 2 nodes, 3 nodes, okay, every time you run 2-3 iteration is fine. When you have 1 million, 10 million data, every time you want to insert a node, you need to run 10 million iteration. Then you can reach the end. Then you insert 1 node. Then the next iteration, you need to repeat the same procedure again to insert the second node. That become not very good algorithm. By resolve this problem, same trick like what you see in the site list. I just declare a new variable called tail pointer, and then this tail pointer is always at the end. At the end, point to the last node. And every time I insert a new node, I update the tail pointer. That is good enough. So all this you need to be flexible. You need to depend on the question, the application you need to design your data structure and the function. So would it be very relevant? Yeah, doubly linked list, circular linked list, all this. Yeah, you just need to modify this singly linked list a little bit, introduce another addition, a few more additional pointer, or trying to like circular linked list will be in one of your tutorial question. In fact, it's nothing. If you look at your linked list, any linked list, singly linked list so far you have learned. Can I have, yeah, maybe this one. What is a circular linked list? Actually, it's nothing. It's just like instead of the last node is the null pointer. The circular linked list just let the last nodes point to the first node. Then you'll form the circular linked list. That you can see in your tutorial, first tutorial. Okay, so this is the function you can use. But I have to say that don't blindly memorize the code here. Here is just some example I show you. In the letter, I trying to reduce the number, all this code appear in the slide. I'm not intend to show you all this code. You're supposed to implement by your own, and it should be depend on the problem. You can change all this function. Yeah, you don't have to fix this. Depend on your application. You will find that you need to introduce another pointer to make your program run better. Of course, you have to go ahead to declare another pointer. Don't always stick with this particular function. Actually, it's just wrote by me. It's not a standard particular function. You have to memorize it. No. So try not to go to memorize all these things. You're trying to understand the idea behind a linked list. If I want to insert a new nodes, yeah, the order, how to update the link. Once you figure out the order, then you implement it accordingly. Yeah, that's the purpose why I don't show you the remove nodes. In the lab, I would like you to go and think about it. What is the order you want to remove a nodes from a linked list? What is the step you need to do? Once you come out a systematic procedure to remove a nodes, then you're trying to realize this procedure into a program. That is from algorithm to a program. Yeah, that is what this module you're supposed to learn. You have a problem, you want to remove a nodes. And how are you going to remove a nodes? You after you figure out the order, the step, and have a very clear, systematic, well-defined step, every step very systematic and very clear, then how you realize this step into a C program and write a program and let the computer do the job for you. That is the key you need to learn. Not trying to memorize all the code in the slide. All this is just some example to give you some idea. Sometimes you may find that some example may be not good enough. You can do it even better. Yeah, that is okay. You can go and improve it. Okay, so that is the linked list. All about the linked list you need to know. Yeah, so in summarize, the array can be random access. You give me the index, I can go to access anyone. But the drawback is very hard to expand it, very hard to rearrange the order. The linked list, not only this, I can easy to swap the nodes location. Yeah, but for array can be quite troublesome to reorder the array. And insert nodes and remove nodes array is I would say is totally not possible. Yeah. So and then linked list, they can let you more efficient and fully utilize the memory, especially when you have a resource constraint. You have limited memory. Yeah, linked list can let you use just good enough memory space to store the data. Array, a lot of time you have no idea how much data you need to insert. You always create a large array, so that is not very good idea. So that is the difference between the linked list and array. I'm not saying which one is better. It depends on your problem. Yeah, today you find that your problem, you know that always you only have 5 items. You always only have 10 items in the data in this particular problem. Of course, you should create an array. But if today you want to let the user decide the problem size, You want to let the user decide the problem size. You want to let the user key in the data by their own. You even allow them to increase and decrease during the execution times. Then of course, LinkedList is the better option. So that is the thing about the LinkedList. The assignment I'm trying to release it in this weekend, and then next week the tutorial and the lab is already available in the NTU Learn, and the lab we only discuss the first 4 questions due to the time constraint. Probably I don't think your TA have enough time to go through the other practice question. I just try to give you a few more questions. You can go and try and play around with it to practice it. Yeah. So yeah, that is the what we cover this week about the LinkedList. Next week there's no programming stuff. It's all about the analysis of algorithm. Okay, do I have the schedule? In the next lecture, I'm going to cover my schedule. So yeah, next week will be analysis of algorithm. This one is all mathematics. Okay, you will find that you need to know what is the series, what is the how to use a series, how to calculate the geometric series, all this. Yeah, because when you analyze the algorithm, like just now what you see, always there's a while loop, there's a recursive function, and when you encounter all this, you will involve some mathematics. Yeah, there's no programming stuff next week. And yeah, we will introduce you someone asking about the big O notation. All the asymptotic notation will be covered next week. And there's a tutorial next week and the lab. Okay, so just take notes. Then after that, during the Chinese New Year, that week is week 4. So there's no tutorial and lab in week 4. Yeah, but then we will cover the stack and cube. Stack and cube, you can consider is a special case of a LinkedList. Yeah, so that will cover in week 4. And I think this weekend I will release I'm trying to release the assignment to you. Yeah, you will receive the instruction about it. Okay, so that is the today lecture. Any question about the LinkedList? So for the new function, seems more complicated than the original one. If you're talking about the LinkedList, yes and no. It's like you're trying to introduce more. In the last few slides, you can see that I'm trying to introduce. Okay, all the way to the last slide. When I trying to introduce more things into the LinkedList, it look like the structure. Yeah, you need to introduce another structure on top of the list nodes. Look like maybe it's more complicated, but actually it's simplified some function, like side list become one line. Yeah, I just need one line. I just return a variable. It's good enough. I don't need to run a while loop to check the size of the linked list. Is it make it more complicated or not? I think yes and no. Yeah, at the beginning, the structure, I introduce more member. So I use a little bit more memory, just one new variable, one new member in the new structure. I can save a lot of computational times when I check the size. So that is one of the benefit. And in fact, another maybe a little bit better is you don't have to write that kind of a pointer to a pointer. You will find that actually you will somehow simplify your prototype, become a single pointer. but it's not really a exactly this thing not really a point, just a single pointer. It's just like inside the linked list there's a pointer in it. So actually it's a pointer to a point. It's still a pointer to a pointer. Because as long as you want to modify the content, you have to pass a pointer. If you just want to use it, use the head pointer, use some variable, the value, then you can just pass by value. What is the meanings when you learn in the previous module? Yeah, the difference is like pass by pointer, pass by reference is you want to modify that particular variable in the main function, in the function, in the in the main function. And if you just want to use the value, use the content for calculation, for some other purpose, you just need to pass by value. Yeah, so that is the difference. Okay, so if no other question, that is today's lecture. Thank you. Stop streaming.